Welcome to my pitch on robots and sustainability. My name is Matthias Rehm. I'm professor for human-machine interaction at Aalborg University in Denmark. So I'm going to talk about robots and sustainability. But I will not start a discussion about what a robot is, but instead I will give you some examples later on the slides. I'd like to start with the definition of sustainability instead. So according to the United Nations, sustainability is concerned with meeting the needs of the present without compromising the ability of future generations to meet their own needs. Often, sustainability is used in relation to environmental or climate challenges, but indeed it also encompasses economic and societal challenges, which has been noted by recent publication from McGill University, stating that sustainability is not just environmentalism. It also includes concerns about social equity and economic development. I'd like to stress this more complex view on sustainability, as my own background is in human-machine interaction and not in green tech or environmental challenges. So what do I mean when I talk about sustainability? My focus is on human factors in the interaction with technology, for example, with robots, which we do talk about today. So the challenges we face in this field in relation to sustainability are thus primarily concerned with social equity like inclusion, diversity, or health, among others. And such interests are represented in several of the UN's Sustainable Development Goals, like the 5 we can see here on the slides. So let's look at some examples from my research group on human-machine interaction. We work, for example, with indigenous groups in Namibia using technology like VR and 3D games as a means for safeguarding intangible cultural heritage. So social practices around living in the Kalahari Desert, for instance. In order to create a voice for these communities and let them become the curator of their own heritage, we use co-creation and participatory methods in order to empower them in the use and appropriation of these new technologies. Another example is our work with citizens with acquired brain damage, where we create personal robots with them to support daily practices like shopping or scheduling of activities. By doing so, we allow them to regain a little independence back from their care personnel. So how does this relate to industrial applications and robotics then? So currently the EU is pushing towards a shift from Industry 4.0, which was focused on automation and data-driven production in the so-called smart factory, towards Industry 5.0, which instead focuses on resilience of companies, sustainable production, and here this means environmental friendly production and human-centric development. And this, of course, brings us back to the sustainability challenge on social equity. The vision is to use technology, for example, robots, for empowering workers and thereby endorsing a human-centric approach to technology. And when we look at the suggestions of or for enabling technologies for this, then I actually get into a very good mood, because it basically reads like a list of the topics that we work on in our lab. So for example, speech and gesture recognition, intention prediction, tracking physiological states like stress, using mixed or virtual reality for interactions, and so on. So let's look at some concrete examples in the field of robotics. One big health challenge, for instance, in the production industry, are ergonomic risks. And here on the slide, we see some typical risk factors, for example, heavy load when handling material, bad posture, or repetitive stress injuries because you have to do the same task again and again. In this project here, our PhD student Marieke Koch van den Broek investigated the use of a collaborative robot for preventing these ergonomic risks. In her scenario, the worker's posture is analyzed using computer vision, And this allows the robot now to force the worker in a more ergonomic posture when they work together on a product in order to prevent back problems, which then, of course, will allow the worker to be longer productive. Here's a different example about mobile robots. Many hospitals make use of mobile autonomous robots for transportation tasks. For example, for bringing dishes from the kitchen to the elevator. And here we can see an ideal context where the robot can drive without any disturbance in an empty corridor. Our PhD student Christina Thornbjerg has done an ethnographic study in different hospitals and in Denmark, and she found that it really looks like this, right? So there are often obstacles in the way, and there are people down there in the basement moving stuff around or moving patients around. Thus, while the robot is solving one task, in this case for the kitchen personnel, it often disrupts many other practices in the environment because it will often stop and block the whole way due to safety concerns when it comes across other people or other objects. So while it's a good option for the kitchen stuff, it's not a very sustainable solution for the hospital as such. So if we want to increase sustainability, we have to move away from a view where a robot just substitutes one specific task to a more holistic perspective, taking into account that the robot shares a dynamic environment with other actors, and that has to be aware of other practices that go on at the same time. My last example looks at human-robot collaboration in production industry again. So in the DrapeBot project, we are investigating the collaborative draping of carbon fibers using a heavy-duty industrial manipulator, which has a payload of around 300 kilograms. Usually, you would put this robot in a cage, right? Because it's very dangerous, it can hit people and actually, in the worst case, kill them. So in this project, we use it as a collaborative robot, where the robot, as you can see here, is, for instance, transporting material together with the robot. Thus, safety and trust become very relevant factors because in order to recognize trust of the worker towards the robot, we analyze movement of the user, relating subtle changes in movement quality to changes in trust towards the robot. This is part of a larger research challenge looking at evaluating the quality of an ongoing interaction, making use of data that we can collect during this interaction. And this, in the end, will allow for dynamically adapting the robot behavior to individual users. Apart from being a safety measure, this will facilitate inclusion of, for example, older workforce or special needs workers because the robot can adapt to different abilities, be it physical or cognitive abilities. So this brings us to the end of my short presentation here. If you want to know more about the work in the HI Lab, you can visit our website or check our LinkedIn page. You can also find some additional robotics-related activities at Aalborg University here on the slide. And last but not least, if you're interested in studying robotics at AU, you are in good hands because AU has been ranked consecutively as the best university for engineering education in Europe. So thank you very much for listening, and I'm looking forward to a lively discussion.